Hi, today I will show you how to create a .NET Angular application in a few simple steps, using Visual Studio Code and GitHub Copilot. First, we need to create the main folder for our project. We will also need separate folders for the Angular application and the Web API. The next step is to generate the starter code for the Angular application using the Copilot command. Copilot will ask us for permission to install the necessary tools to run an Angular application on the computer, such as the Angular CLI or Node.js. The next step is to check whether the Angular application runs using the npm command. As we can see, the application has trouble starting. Do you already see where the problem is? Yes. We are in the main project directory, while the correct folder for the Angular application is Web. Let's try running the npm run command again. Something is still not right. The response we received is a list of available npm commands. The correct command we're looking for is npm start, so let's run it. Now we can see that the application is starting correctly. So let's move on to the next step, which is creating the .NET Web API application. When you write commands, remember to be as precise as possible. In the previous step, I forgot to specify the directory for the Angular application. Copilot figured out on its own that the correct folder was Web. This time, I will specify exactly where the API should be created. Now let's open a new PowerShell window and then run the .NET commands to build and then start our backend application. We can see that the application has compiled and started successfully. To confirm that the API is working correctly, let's check which methods it contains. Our starter application contains a controller that returns weather information, which we will replace at a later stage. So let's focus on creating an additional controller that will return a list of products. For this purpose, we will use a list of randomly generated objects. How to store and manage data using a database and entity framework is something I will show in a separate video. As we can see, Copilot has already generated the code for the new controller, along with a list of objects containing test data for our application. Before committing the code, always carefully review what has been generated. In this case, we can see that the product class, which describes our test records, was created in the same file as the controller. This is not a good practice, so to keep the project organized, I will create a separate models folder and move this class there. Remember to update the namespace to reflect the new folder where the class is located, and to import the new location in our controller. Now, we can remove the previous weather forecast controller and its related class, as we no longer need them. Since we now have a working API that returns data, it's time to go back to Angular for a moment. The default application contains an app component, which in principle should not be responsible for displaying any information, but only for rendering other components defined in the application's routing. So let's create our first component, which will be responsible for displaying the home page. We'll call it the home component. While the code is being generated, errors may appear in the console if the application is running, so you should always wait until Copilot completes its work before you start verifying them. Now let's review the code of the newly generated component. By default, this includes a TypeScript file containing the component definition, an HTML file, a CSS style sheet, and a spec file with unit tests. We'll leave the topic of testing for a separate tutorial. As discussed earlier, the HTML code in the app component has been removed. What remains is the router outlet, which is the placeholder where components will be loaded according to the routing configuration. And that configuration has also been created and already includes our first home component. Now let's check whether our application works after the latest changes. As you can see, the text on the home page has changed and now displays the content of the new component. So let's move on to fetching product information from our API. For this, we will need a service that will handle HTTP requests and retrieve the data. Then we will display it in our component to verify that the communication works. Our component has been extended with the implementation of the onInit interface, which gives it the ng-onInit method. This method is called after the component has been successfully initialized. We can see that our service responsible for communicating with the API is now being used, specifically its getProducts method. Then, the subscribe call listens for the response from the observable. The content of the Lambda function's next block is simply mapping the received data into a list of product objects, which we will eventually display in the HTML template. In simpler terms, when the component starts, we fetch data from the API, store it in our product list, and thanks to that, we can later show it to the user on the page. On the API side, the program class has been updated with a CORS policy configuration that allows our Angular application running on port 4200 to communicate with the API running on a different port. This is necessary because the browser blocks such requests by default, and proper CORS configuration enables them to be executed safely. Let's now check whether the product list is displayed. It looks like the application got stuck in the isLoading state. Because of that, the first thing we should verify is whether our API is correctly returning the list of products. To do this, I'll open the browser console, go to the Network tab, and then inspect the response. As we can see, the products are being returned in the response to our request, so we can assume that the issue lies on the Angular side of the application. In the version we're using, with the current syntax and data handling approach, we need to adjust the component code so that Angular correctly refreshes the view. Without these changes, the application doesn't update the displayed data and keeps showing the initial value. As we can see, Copilot didn't account for these details right away, which only confirms that we need to stay alert and carefully review every suggestion. This time, the application displays our list as expected. If you enjoyed this tutorial, please hit the like button and subscribe to my channel to be notified about new videos. Thanks for watching.